Good afternoon. Welcome to today's afternoon discussion all around okay, Riedel MediorNet. That's today's topic. So joining us today is Jeff Sullivan from Riedel here in North America. Thanks for making time, Jeff. This is a crazy period in our industry, and you guys, I know, are going 100 miles an hour. All of us asking a lot of the same questions, a lot of us asking different questions. So thanks for the priority that your company is making in educating all of us and helping us to understand things that are atypical applications. We were talking about that before we started here. This is a time when we need to think differently. We need to embrace ideas that maybe fall out of our normal scope of work. And that's kind of what today's discussion is about. MeteorNet is about, you know, if you're already running Artist, or if you're even if you aren't, looking at what this single backbone, being able to carry audio, video, comms, data, we're going to keep this unified. We have a single management point. A lot of benefits here, and then obviously if you're currently running other Riedel products like Artist, this is just a natural extension, right? So before we get into the topic, I see a few more people are logging in now, and we'll let them keep joining us. Pete, why don't you talk a little bit about our Q&A time today and how we're going to handle that?
So on your screen there on the right hand side, there is a little pull down window that has questions, and in that you can type a question and send it to us. Not all of the questions will be viewable to everybody, but we'll see them all. And those that are just actually questions, we will pass on to Jeff. There are, I think a couple of people may have had the time wrong, because we saw a lot of people log in really early, like an hour ago. 2 people logged in when we were logged in, and but we're starting now at 3, which is our real time. So Jeff, go ahead.
All right, Pete, we're going to go ahead, right? No more filing in. I'd just like to start off and thank everybody for joining us here today to learn about Riedel's MediorNet product. It's kind of a video router out there in the world, but a lot of people use it for a lot of different applications. Some rental houses are using it to move their comm system around, move your video around, move your audio around. All of these things can be achieved by MediorNet. Matter of fact, I just built a production truck recently here in the US, our first production truck running MediorNet for touring video. It's a really nice project, but we'll get into some of that as we go along here. We've got a few hours to deal with everything. So some MediorNet training. You know, what is MediorNet? It's a fiber-based signal distribution network, right? We're distributing all of this HD SDI, SDI, 4K, any kind of video that you can imagine across this system, as well as audio and comms, artist panels, AS67 network. So when you're doing these conventions and such in these large convention halls and you need to move things around that venue, and the very large space, like Anaheim Convention Center this year did BlizzCon with MediorNet, and it was a very successful installation. Just moving everything from all of the stages all over that convention center. And so just imagine like the Denver Convention Center when they do stuff, they're moving things around through the Denver Convention Hall, one of the recent conventions that Touring Video was dealing with, as they had multiple rooms and moving stuff around. But with that, you get signal processing. You get the multi-viewing, and we have 2110 bridge products, so you can bring 2110. Somebody says, hey, I wanna bring 2110 video into this system. How can I do it? Oh, it's the 2110 bridge app, and we'll get into some of those things. But it most of all is an intelligent fiber utilization, a TDM-based network. We're all typically used to saying, oh, I want to move one signal from here to there. We throw down a media converter, and well, no, we're moving things around. But with MediorNet, you're going to be moving more than one video source or audio source over that piece of fiber. So in this day and age where people are charging hundreds, if not thousands of dollars for dark fiber through a convention center. This could be a real cost savings to you guys out there in the field. So what's in the portfolio? What do we have? What makes up the system? The MeteorNet the MeteorNet Metron is our core backbone of the system. There's 64 ports on it. 32 of those can be used for 10 gig. We'll see one of those a little bit later. Modular frame, it's an older system, but a lot of people still have it out there in the world. We don't currently sell it other than very specific projects. You have the compact, cost efficient, WDM built right into it. What are you going to do with that? Well, you can throw a FiberCon connector right in the front of it and get your 4 fibers connected instead of playing with your ST fibers. Some discussion there on how you want to do it. And it's scalable. There's 3 different editions of it, but it's the only one that right now primarily has card-based applications, and you can change out the card in the upper right portion of the device. You also have analog audio inputs and analog audio outputs with MADI and AES3 on that one. So there's a little bit more connectivity in that unit in and of itself. My favorite product right now is probably the Micron. The Micron allows us to run 4, 5 different applications really out there in the world. And this unit all by itself, this 1RU unit, is a 12 by 12 router with 2 MADI cores in it, a network port on it so that you can move it to another device. And there's the point-to-point app down at the bottom. And so this one piece of hardware can become multiple pieces of hardware essentially for you. It is a software-defined hardware, if you will. And so you can run any one of these applications on here, allowing you to achieve different things. If you want a multi-viewer, you run the multi-viewer app. We'll get into that in the IP app and in the processing app and the base app. But the big thing here is also looking at the topographies and the possible topographies that you've got out here with all of these devices on that right-hand side of the screen and the topographies. The Metron allows you to really add in different units, obviously with 32 cages allowing you up to 10 gigs, but the Micron itself only having 8 cages, 10 gigs a piece. So you can see where you might want to just do a single unit frame sync on every input and output. You have a point-to-point application, you can ring them or you can mesh them there. That's what you got going on there with the Micron, and all of them really allow for this kind of stuff. It's all based on what bandwidth and what you're building out, and we'll get into actually building it out. The MeteorNet modular frame here. This is the modular frame that we talked about. It's 2RU unit, card slot based. If you see this out there in the field, it's primarily something you're now going to be just seeing out there in the field. 2RU processing cards, link cards, media cards, 8 IO cards possible to put inside of there, redundant power supplies, 16-channel backplane, fan module, all these things that you can move in and out. This was a really early frame, still a great frame if you see it out there in the field. A lot of people strive to get this frame, but unfortunately we're not really making them anymore. We do spec them on very specific jobs, I'll say that much. MeteorNet Compact, here's the Compact. 3 different variations of it, 3RU frame. This box is really, to me, highlights the ability to throw this up into a press box next to your announcers. You get your video, you get your audio, you get your comms panels, and all of those things up there in a highly dense format. Here's our 3 different variations. You can see the things just build on top of one another there, the basic, the plus, and the pro. Basic and plus don't have the card options, but the pro does. All of these, there's many different fiber options for these devices. I'm not going to go into those today because there's truly too many to get into in a 3-hour presentation. But definitely talk to us about the different kinds of connectivities here. 4 video inputs, 4 video outputs on the Pro, 2 on the Plus, and 2 on the Basic. So definitely a very useful tool to have in your arsenal. The mic inputs are mic inputs, and there are preamps built inside of there. 2 inputs and 2 outputs on the Basic and the Plus, and the Pro you get 4. It's also 3 AES3 inputs and outputs on the Pro, or it's 1 and 1 on the Basic there. But if you want more details about that, definitely hit up our website to get you more in there. Some more, the details there. GPI, if you want to move GPI out there in the field, very useful. The Pro, you'll see, has GPI, whereas the Basic and the Plus don't. All right, here's the big guy right now. Here's my favorite unit out there. Micron. On the left-hand side, you'll see the link cages. There are 8 of them. Each one of those allows up to a 10 gig SFP. So that's 80 gigs of connectivity out there to your TDM network, and we'll get into how the TDM network works later. 2 MADI cages next to them, right? So 2 separate MADI cores going into the box and out of the box. 12 inputs, 12 outputs on the SDI. Embedded audio on all of those, no special software licenses for that. You can embed and de-embed. You can pull things off the MADI and embed them, reshuffle them, all that kind of good stuff. You also have a sync input and a sync output. The sync input, if you're not utilizing it on that box, can become a sync output. So you've got a lot of different options there that you can go with. This one small 1 RU unit. Again, I built an entire production truck based off of these units and the Micron Metron connectivity in the backbone. So 10 gig link speed to the TDM network, sync references in and output, everything's 3G on here, gigabit Ethernet port. So you can actually start routing your Ethernet around your venue. You need connectivity to POV cameras and such. You need connectivity to front of house stage audio console or the like. You can do all of that here. OLED display on the front to start controlling everything, single knob, 2 buttons on either side of the display to start going through. The glue features on this, on all MeteorNet test products, or all MeteorNet products you'll see in the field, and we'll get into a lot more of it later, is you can bring up on-screen displays, the frame syncs we've talked about, the embedding we've talked about. You can bring up test patterns, and we'll see a lot of that when I get more hands-on later. Apps, okay, everybody's familiar with apps on these little phone things that we've got out there in the world. That 1 RU Micron, and I talked about the apps earlier, but just the standard applications, we've got 5 of them. So the standard is the gateway application. The multi-viewer allows up to 18 pips across 4 different heads. Net-wide time configuration, easy configurator. Processing app, we're going to get all of these. There's a slide for every single one of these. Processing app allows color correction, up-down cross convert. And there's actually 2 multi-viewer heads inside of the processing app. And then there's the gateway app that we started to touch on, is SMPTE 2110 compliant. And I like to think of that, not only can we move video there, but we can move audio. You'll notice the 2110-30 and 31. So maybe you're looking to just get 2110 audio or AS67 audio into an embedder. Well, here's your option, guys. Here's a good way to go. And all of these can be loaded on, and they're all software defined hardware. So standard application, and sorry, it might be a little dry, but I always think you need the building blocks before you get into really building out a system. So you got to understand it. So bear with me through the PowerPoint presentation if you could, thanks. 12 SDI inputs and outputs, we talked about that. 80 gigs to the backbone connectivity, the MADI ports. We have the Ethernet tunnel the integrated signal processing, frame stores, frame synchronizers, audio embedder, de-embedder, automatic format detection. So it knows what you've plugged in and will tell you what you've plugged in. You don't have to go to your scope and go, hey, what is this video format any longer? And you can generate test patterns. You can generate test tone. On-screen displays, time code, VITC, all those good things, audio sample rate converters, all built into that standard application. So when you buy this box, you'll also be purchasing an application with it. You can purchase multiple applications. I'll show you that a little bit later today. Use case examples, standalone operation, 12x12 router, 12 frame syncs, delays. Point to point, you want to have a stage box. You want to get from your front of house production to the parking lot. This might be what you're going to use. But distributed routing with integrated processing built into that application. Okay, multi-viewer application. Love the multi-viewer application. 18 pips. So you have 18 pips that you can divide amongst 4 different heads. And that can come from anywhere in the MediorNet space. Anything you've got connected in there, as long as there is bandwidth to get from that box where you're bringing it in to this multi-viewer. It doesn't matter. And then this multi-viewer can leave. It doesn't have to come out those inputs and outputs on the front of the multi-viewer. It is to come from anything in the MediorNet space on that TDM system when you've built it up. So 4 screen outputs, rotatable, routable to any MediorNet output. Net-wide configuration storage. So all these configurations you build can be loaded into any multi-viewer across the entire system. You've got your favorite multi-viewer that you want to put on some other unit somewhere across the net. You just apply it, and we'll get into that later. Distributed time code and counters, all of that stuff. Easy configuration, fully controllable via Ember Plus, TSL 5.0. So, you know, we love to have our tallies and our multi-viewers. That's how you're going to get it in there, is Ember Plus and TSL 5.0. Various widget styles and customization options, clocks, pictures, all those kind of things. PIP display, including tally and UMD. UMDs follow across. They can also follow from your TSL or your Ember Plus devices. So if you change a name out there in your router control system, it'll change on your multi-viewer. Audio bars with, you know, scales, flexible thresholds, all that. Want to monitor your audio right there in the pips? There you go. Analog and digital time displays. Behind me, you saw that clock rotating in the background. That is our clock inside of there. And you can have counters inside of there. You can trigger counters. So let's say the producer, you know, wants to count down 1 minute to commercial break. She can trigger her timer, and it'll count down there in a timer in the multi-viewer window for her. Easy configuration. New concept of net configuration is quite unique in the market. It's net wide. You know, this is not downloading a file and uploading a file. You'll see all of the multi-viewers across the MediorNet system whenever you load the multi-viewer application to start building your multi-viewer. Easy transfer of net configs to devices and configurations, fully supports Ember Plus, drag and drop, MediaWorks. All multi-viewer configuration is done in a single window. So there again, all of your multi-viewers are configured in a single window. Predefined layouts to make your life easier. Here's some examples. It's really kind of important to get through. So you have 18 pips. You can cut them up however you want, but still only 18 pips. Jeff, can I reuse pip 1 across all of my windows? No, you cannot. So what does that mean? Scenario 1, we have 4 quads. Scenario 2, we have 2 9 boxes. Scenario 3, we have 1 9 box and 2 quads and 1 pip with one window with 1 pip in it, or we just have all 18 in a single. Okay. Micron processing app. This is new. First production truck in the world to have it was the one here in the US. They love it. Full up down cross convert, 2 channels, 4 channels of color correction, full color correction, 2 9 pip multi-viewers, Ergo, again, you can route those multi-viewer heads out anywhere in the MeteorNet world that's connected. It's all based on licensing. So you purchase a license and you can switch your standard over to this, and I can get into that later. RGB color correction, wireless and pocket cameras, displays, all these kind of things, you know, that you'd want to do, POV cams, those kind of things. That's what you're going to use the processing application for. All right, the IP application highlights bridge between MeteorNet baseband and IP signals. This is how we're getting that 2110 into our plug and play TDM system out there in the world, right? We really need to, you know, think about that. And I've had a few customers that say, hey, I don't want to send an email every time I need to make a video route because something's not working. Well, you know, that's really one of the big sweet spots of the baseband TDM side of MeteorNet. It's all plug and play. There's no certifications you're going to need here to really start running this product. But if you want to start taking in those 2110 feeds, you can. And all you got to do is buy an application for a product that you may already own. So we can start converting that from IP to SDI. But that's your bridge. That's the application you need to purchase, right? Standard compliant, full 2110 compliant, JTNM tested. 4 video encapsulations, 4 video de-encapsulation. So that's just the onload and offload, 4 in, 4 out on that 110. You can see that on the left there of the device in your upper right-hand screen, you see an orange box. And earlier I talked about those 8 cages. Well, using this hardware and the software, the IP bridge application, you actually only get 40 gigs of connectivity to your TDM net, but that's not so bad really, because we're using one of the cages, and you see that bright yellow box there in the upper right-hand corner. That is the one that is used to bridge to the IP network. So you would actually use a traditional 10 gig SFP, and you would plug into there, and you would plug across to your Cisco or Arista switch, and that's where you would start moving video in and out. And that doesn't mean that you don't get some baseband video connectivity on this product in and of itself. You actually have the 2 green boxes, the solid green boxes, 4 ins, 4 outputs, HDSDI, all the way up to 3G. The dotted green box down there, the lighter green box, you're actually going to be able to see a mirror of the signals that you are sending out of this box in the IP world. And you still get your sync and you still get your config port. Just know that when you're running certain applications, we have to take a little nod to the fact that we're using different processing power inside the box. And so we may lose a few things. That's why we're going to lose some videos. It's just different processor that the FPGA, you know, is required to do the inputs and outputs on the box. But it allows synchronization to the MeteorNet system over PTP. It's NMOS ISO4 and ISO5 supported. You know, moving your cameras in and out. Interface to standalone IP devices, connect MeteorNet systems over IP. Yay, it's the Metron. I promised we would get to this thing. And that wraps up applications. We didn't talk really about point-to-point, but point-to-point is your standard application that just goes from one box to another. It is a one point to another point. All right, but full routability inside of point-to-point. So 2 microns can run an application for point-to-point, and that is your stage box, right? Basic, simple thing. All right, the Metron. 64 high-speed ports. The first 32 ports, those are the top 2 rows, 10 gig capable. The bottom 2 rows, okay, 4.25 gig. 3 sync inputs, outputs. It's 1 input, 2 are outputs, and then 3 Ethernet. It's on there. 2 are for tunneling, and 1 is for configuration. Same OLED display we've seen across all the other devices. Redundant power inside of here. But this is what you're going to start using to connect bandwidth between your microns. If you start outgrowing a mesh system, you're going to want to add a Metron inside of there, and we'll see how to build a network later inside of this presentation. Main system characteristics. Sorry, so different talking to your computer versus talking to a class, guys. So this is your main backbone, you know, that's 64 ports. We've talked about everything else we've got going on inside of here and what's currently supported inside of the Metron. And here's what happens when you start outgrowing that mesh and you want to start linking meshes together, or you want to make this the center of your mesh. You can just start adding your Metron into the center there and start moving more video between all of these different things, because ergo, again, we only have 80 gigs of connectivity on each Micron. The Metron has a significantly more, right? If you're using the first 32 cages with a 10 gig SFP on there, that's 320 gigs of connectivity. So significantly more bandwidth to start connecting everything together. Integrated applications, you know, central video router, right? So you got to think about a centralized video router, a 92 by 92, you know, system, the redundant configuration, audio embedders, delays, all that kind of stuff. This can be your core system inside of your production facility, be it a truck or a fly pack or a studio, right? And you can start dividing these up, or you can stack them. I've seen some facilities that just decide, you know what, I'm going to replace my core router with this because I want to get rid of all of my external embedders and de-embedders. It's still very valid, but this is what you can do. And just add a Metron in there and connect everybody through. But you can also decentralize everybody and move those devices out amongst the pieces of equipment, be it, you know, a mile or two away or in the same venue, right? This would be a perfect application for a stadium where instead of having media converters sitting around the venue, right? We have our Metron at the core up there in our equipment room. Maybe we have some Microns sitting there next to our VTRs, but then we've got our patch panels all around the venue. Typically those patch panels around the venue are significantly too far out of reach to run HDSDI over existing copper cabling. So you're gonna have to convert this to fiber optics somehow. Well, why not do it intelligently with something that allows you to pass multiple signals over one piece of fiber? And you're gonna a lot of times connect stuff like that back to a router. So why not just decentralize your router, right? Move all these devices around where you need them. It's perfect application in a production truck. When we did the production truck, our tape rack had a few Microns and they were at the top of the rack. So we had very short cable runs to all of our tape decks. Our switcher had 3 or 4 Microns sitting on top of the switcher. We had units sitting inside of the rack with our CCUs. And so all of this just became very, very short cabling. And not only, you know, just the weight that was saved compared from copper cabling to fiber optic cabling, but the man hours of installing these things, right? You know, pulling in a couple hundred feet of copper through a floor versus just pulling in some fiber with a blow tube and plugging things up, and then things being on 3-foot cables. It's a significant savings there that you got to start thinking about when you start decentralizing. And decentralizing is all we're really talking about when we start talking about going to 2110, because everybody wants to start putting those devices out there where the inputs and outputs are. So we can do that here and just over the TDM network, and it's all plug and play, plugging in devices. We'll see that a little bit later. What kind of topographies can we do? Topographies are important, right? We can do the ring, we can do the star, we can mesh, we can do point-to-points, we can daisy chain. I mean, you can just standalone too, just one device out there. Hey, I want just a 12 by 12 router. There you go. All of these are capable inside of MeteorNet. And I use all of them, and all of them I use for different reasons, right? I'll mesh inside the production truck. I'll do a daisy chain maybe out in the field, but it's bandwidth optimization, you know, using that fiber, you know, 10 gigs instead of a 1.5 gig, which is your standard HDSDI signal, or 3 gigs, right? So we get 10 gigs to cut things up. Carry frames, everything's divided into time slots. So here's where we're gonna start really dealing with our time slots, okay? We're gonna start dealing with how we start dividing everything up and what that TDM network is really doing. So, and it's time division multiplexing, okay? So every little blip of data has its slot, you know, and everything's divided into 6.4 megabits bandwidth. It's matching an AES3 frame. Kind of strange that we're an audio company, we're matching an AES3 frame with video. 512 slots available per 4.25 gig link, right? 512, 206 megabytes equals 3.25 gigabytes of bandwidth. Each native signal is sliced by the FPGA. So everything is sliced up right there in the Micron. Each one of these slices are carried by the mentioned time slots and transported to the central router of the frame, the FPGA, the processing card. So everybody's sliced up in there. Everybody's existing in these slices, but everything is just passed in this bandwidth through these little slices, these little chunks, right? So we start stacking up our chunks. Say we push out an AES3 frame because we're passing audio. We'll give it a few more, then we want to pass in some MADI, and we just stack these things together as need be, and our video as need be. And everything is in time in the system. It's very important with a TDM system, right? You need to know where every slice starts and stops. So timing is very important. Everything across the network is in time. It will always be in time if it's connected to the TDM network. The other thing to realize is that HDSDI signal, that MADI or that AES stream, obviously the AES streams, you know, they'll one chunk, but the MADI or the HDSDI, it's something that's a little bit bigger, will always exist on one fiber. It'll exist on one fiber going to another device. It doesn't divide it in half and then try to send it down 2 different strands of fiber. It's not the best way to send a signal if you want everybody to be in time, or you know, you want to send several SDIs. It's all sliced up and put in there. So everything just, you know, across a 4.25 gig signal here, sliced up and packetized and sent across. Right. Here's another good example straight out of the manual, really, just how everything is divided up and then parsed out over a 4.25 gig link. Goes to another device, the device pulls out what it needs, adds in other things if it needs to be. And so it's just intelligent use of the equipment and the fiber out there. All TDM slots are created by the MediorNet cards and sent to the processing cards. Meteor transports these slices one or more multiple destinations within the system. So, I mean, just because a signal is going through a device doesn't mean it actually needs that signal, or if it does, it'll take it out and it'll still on pass it. So just because that, you know, train car's on the train doesn't mean that the conductor at that station needs to pull it off. The freight manager's not going to pull it off, but if he does, he pulls it out and, you know, can still on pass it. So, but just know a link will never be split. All right. So it's at this point in time in that first presentation that I think we could take some questions if there's anything currently going on, guys.
Right at the top, Joe Serra asked, can it handle Dante? Or more specifically, can it be a switch for Dante?
Well, it can pass up to gigabit network traffic. So the answer is yes, it can. You can.
But is that one tunnel?
It's point to point. With MediorNet, MediorNet is not a switch.
Right.
Okay. It is a transport stream, right? From rack A to rack B here, you know. So I need a network tunnel available over here, and I need one available over here.
And
right?
you would put
So it's point to
regular
point.
Dante switches at each end to do your normal Dante stuff. Think of it only as an Ethernet cable.
Yep, and you can also pass AS67 the same way, 2110-30 the exact same way. If it'll pass over a gigabit network tunnel, it'll pass from here to there.
Okay. Thomas Fuller asked, does Micron support Ember Plus control?
Yes, we covered it in there. Yes, it does support Ember Plus.
Okay. Jean-Francois Baby asks, the dual power supply is only for redundancy. Do you have to use both?
You do not. I actually have both of them plugged in only because I don't want to see alarms, but
okay.
Only for redundancy.
And the multi-viewer app, can it detect input signals or put black in the PIP if there's no signal there? Or more specifically, can any input put something in if there's no signal?
Can any input? Yes, and we'll get into that. And it's your choice what you want to see. You can do a freeze frame. You can do black or blue. It's up to you. I don't like to do freeze frame.
Or a freeze frame from something else.
It's freeze frame from the source. The source would freeze if you want, but it won't. I don't think currently in the software it will do what you're asking.
Okay, Mario Diaz wants to know, over a traditional network, can you ISO manage 4 signals by connection? I'm not quite sure what that question means.
Can I dictate what links? Let's just say he's asking, can I dictate what links a video goes over?
Mm-hmm.
No. It's going to manage all of its links. We don't tell it how to manage its bandwidth. We let it do its job there in the background.
Okay. And Claudio Corcine, Corcione, he says, hi, when I use a calculator to determine the links usage, I get 4 links need 4.25 gig. But when we're actually transporting those signals on an event, the usage of every link is very low. What's the proper way to determine the link usage in this example?
We'll get into the link calculator a little bit later.
Okay.
We'll see that a little bit later.
So
I'll just leave that to answering when we basically get to the link calculator. And
the load on the link, the term dependent on actual video being there. So if there's no video there, there's no audio there. There's no transport going on there.
If there's no video, it still reserves the bandwidth, but it won't be passing anything. And I haven't said it yet, but this is all uncompressed. Okay, there's no compression engines in here. There's no J2K encoding. There's no MPEG encoding. There's no encoding in any of these devices, right? All of this is uncompressed video, and that's really important to notice about this product. It's real time passing, everything across.
How many channels can be handled on each of those MADI SFPs? 64?
Yeah.
64 and 64.
Yep.
Okay. How are you moving 4 3G SDI signals over a single 10G SFP when bridging to and from 2110?
We'll look at so we're using a 10 gig and it's a 3G. So 3G is really using there's not enough bandwidth in there. We'll get into it when we get into the bandwidth calculator, because as I'm recalling, you actually can only move 3 over one 10 gig because there's not enough overhead to move more than 3. So the answer to the question is we're not.
There we go. That's it for now. Continue, please.
All right. I think now is the time that I'd like to get into the software. How are we doing on people? Everybody watching? Everybody okay?
147 people are sitting.
We're holding strong. Everybody's connected.
Somehow I'm keeping everybody entertained. So for this process, I actually need to share my main screen here with everybody. All right, looks like we have our main screen, and I'd like to start showing, excuse me while I arrange my windows, ladies and gentlemen. Okay. So to interact with the product, we need MeteorWorks. MeteorWorks can be found by logging on to your My Riedel account. If you don't have a My Riedel account, I urge you to set up a My Riedel account. But once you've downloaded this software, we can start setting up the devices. Okay, we already have a net built out here, MeteorNet demo, we can see that here. But to connect to the devices, and always most important is how do we connect to the devices, Jeff? First drop down, MeteorNet settings, and network settings, there we go. Okay. We do not have to put in an IP address, a target IP address of a device. I always recommend it. By default, you'll be in dynamic, and it will show up here in your network interfaces on your computer. Hopefully you have your IP address set up in the same broadcast domain so that you can see. Thank you, Joe. All right. So your broadcast domain going on here. Right now I have two Ethernet ports on my computer set up. One is for my internet access so that I can stream to all of you, ladies and gentlemen. And my other one here is to connect to my MeteorNet system. I again recommend that you do a dynamic plus static. What dynamic allows you to do is use the discovery mechanisms built into MeteorNet. It's kind of like Bonjour, so that it'll automatically find that MeteorNet network out there and all those systems out there in the world. But I like to target, this is my little tip, I like to target one of those devices out there in the world. You can do that by just typing in the IP address, a known IP address of one of those Microns, Metrons, any device that we talked about already. You just punch in the IP address as long as it is connected to your network and you can see it and you can ping it, then you can get to it here. So set all that stuff up. We're gonna click OK, and then we're gonna see what happens. Look, there we go. It showed up again. Okay, so there's some things that we can see first off going on here is we have configuration status, it's red. Oh my gosh, look, I got a bunch of new links. So the reason why they're new is because they've changed, something's changed. And before I started the class, I actually rebooted and changed some things just so this would show up here. But when they're blue like this, just means they're new to us. And we can say save all, everybody's gone. And hopefully we're green, great. We can also see our errors and we can see that we have connections in system mode. We can log into the system. And let me tell you, there's two different modes here. It's very important that you understand that there's two different system modes when you're looking here, MeteorNet. Construction mode, that's our ESU day. That's when you're setting everything up and plugging everything in. Why? Because you don't want to see a bunch of errors when you're cleaning fibers and you're going through the entire system. But your production mode, that's show mode. You know, that's the red lights on, the on-air lights on, and we want to see every error. We want the system to no longer dynamically reroute things going on inside of the system. Sorry, force of habit, I just clicked on the errors because they're red and I can see that my MADI is asynchronous right now, and we'll get into fixing that a little bit later. But I can see that, and I can see how many frames I have online. So, okay, let's start going through everything we got going on. I swear to you, there's darn near 4 ways to do everything inside of MeteorNet in MeteorWorks. If I wanted to get to my System Explorer, I can click on this button right here and we'll bring up our System Explorer. We start exploring our system, but if that wasn't good enough, we can just double click on the net and voila, it brings up System Explorer. What is System Explorer? Well, it allows you to explore your systems. You can see your inputs and outputs, all your audios, all those things. We have our we're in our Compact Pro here, so we even have some RockNet. If we had RockNet plugged in, we would see our RockNet channels. Okay, so that's the upper. We have the choice of layout. Why would I have two different choices of layout? Well, one layout here is just to look at everything. We're gonna see all of our inputs, but our second layout here is for routing, because down here, we're gonna see what our destination is, where we're gonna start sending things to. So if I wanted to actually route something, I can see that there are no routes currently made here. Okay, there's nothing connected. How do I know that? Because, wait, hold on. Gotta go to our standard. We'll see our, nope, nothing there. Oh my gosh. Okay, inputs, something changed. We have a green arrow showing us that something is coming in here. We have a connection showing that it is connected to something. So this video, there is video there. There's video there, but there's none there and there's nothing there. And these are good formats. If they were bad, if they were not a format that I had the device set up for, it show up as red. So I start getting information right here, right away. But let me show you how easy it is. I mean, this is, pull up the sleeves real quick here. This is gonna be really difficult. Let's route some video. And now we've routed video. We've got a connection made. But Jeff, you have the color bars on. Look, I can see that I have the color bars on. Test pattern, let's just turn that off. So now we have a valid video source going out there, coming in here, going out there. And I can see that it says Red Bull Air. If I wanted to take party, because this is the video of our, I think, 30th anniversary party, now it's party. If I wanted to take both of them, I just drag both of them down there. Now I've routed both of these down here, and I can see that, oh, I've got my test pattern on all of these. Let's just turn my test pattern off on all of those. So yeah, I can multi-select. But System Explorer really, allows you to explore your system. We saw earlier in our last window that we have 5 frames connected. See right here where my mouse is circling, and you got 5 frames connected right there. Okay, 1, 2, 3, 4, 5. There they are. That's all of our frames connected, and we get to name them. Okay, so if I wanted this to be Compact Pro 1, I'd just name that Compact Pro 1. If I said this ST1, well, I don't like that naming, so I'm going to just say that this is tape rack. Okay, so now I start to know where my devices are just by naming them. So if I want to go to the device that I'm going to call tape rack, I can go to the inputs from the tape rack and I could route them out something. Now, given right now, okay, magic of television, I am going to actually move some signals here. I'm going to break the world. We're going to see one thing went away because it froze. And then I'm going to add a signal over here. Oh, we added it on 7. Let's add it on 1. Boom. Okay. So System Explorer really starts to let us explore our system. And if we want to start naming things, here we can just double click on something, go in and say rename. And we're going to say that this is now the party. Okay. So now we have the party here, but I don't know what the party is. What format is the party? Well, if I double click on it, if that moved too fast, let's go again. We'll double click on this here. We're gonna start looking at, oh, here it is. Here's our total lines advanced, pixel advanced. This is our timing information. We have a video input format is HD 1080 60. Okay, well, we're a European company, and it just so happens that all my videos come from Europe. So we're going to run everything 60 today, but we have to know that, right? And let's just say, okay, well, right now format is set to HD. Well, I want it to be auto. Okay, I want the system to automatically detect what comes in. Now, why would I want to be able to dynamically tell my system, hey, this is HD, hey, this is 3G, hey, this is, any one of these formats here in this dropdown? Well, it's quite simple. It's a TDM-based network. We want to help you help yourself, right? So if I set something up as an HD, this system's going to know that when I route that, it needs 1.5 gigs of bandwidth to route. If I said that this is a 3G system, right, I'm going to need 3G. Okay, so I would want to actually go in a properly maintained system that's not changing a lot. This is not your dynamic field system, right? This is maybe the system that you've put into a studio or whatnot, or any kind of system that maybe I'm out there in the field and I've done my bandwidth calculations, but I don't have enough fiber to run a bunch of 3G, or I want specific bandwidths and I really want to manage my bandwidth. This is actually a way of managing your bandwidth inside of the system. You're telling the system, hey, when you get this routed across your fiber network, your TDM network, you are only going to allow for 1.5 gigs of bandwidth. And that's going to help you out when somebody out there in the field on an esports thing was told to give you 720p and they decided to give you 1080p, right? 3G is, 3 times, well, not 3 times, but still, it's substantially more than 1.5 gigs out there in the world, and we don't want to tie up 3G of our bandwidth that we may or may not have. So it all depends on how you build your system. We'll get into building systems a little bit later, but there you go. That's how you tell what your format is and those kind of things. Other things you need to look at here inside of the system, you can actually mirror an input, okay? So you're mirroring that to your output. You're tying up one of your outputs, output 1, to see what's coming in, right? Test pattern, what is your test pattern? Can we enable a test pattern? And actually right now we're in valid format. We need to be 60 Hertz because that's what we're pushing out through the system today. Do we wanna sample rate convert things that we're de-embedding? But that's the general settings. And then, oh, by the way, this little favorite tab here. So I told you that there was color correction inside of the processing application. Well, this is the standard application that we're running here in the tape rack, right? Micron, and just so that you see there's no tricks, standard. Multi-viewer is gonna tell you that it's a multi-viewer. IP is gonna tell you that it's an IP, but if we go back down here to the video inputs of the tape rack and we go to party, we can actually see that there is some color adjustment on every single input inside of the system now. Every input, you can adjust the brightness, the saturation, the hue. You can either do contrast or gain. Gain, YCBR, contrast, just Y values. So you have minimal color adjustments. We don't call it color correction, but there's color adjustments, something that might just be just good enough to tweak in that esports feed or something that you're gonna put out on a monitor, those kind of things, something that isn't just right, you wanna touch it up just a tiny bit. Every single one of the inputs on the standard application has this availability to you now. Okay, and I like that. I think it's a really nice thing to do. Okay, let's deal with video outputs. Let's go find a video output that actually has something on it right now, because it's no fun if we don't have anything routed out, right? We got to use the device. And I can tell you that we have something routed out of our multi-viewer and our video output 1. So by the way, we're in configurations right now. This is our configurations tab. This is, where you start configuring things. Silly guys just started naming things like sensibly. Okay, so video output 1, we actually have something routed out there. See, we can see that video output 1, multi-view 1 is routed out there. And we can start seeing our little diagram here that we have video coming in. It's going through our de-embedder, our frame synchronizer, caption timecode, our embedder, and it's leaving us and how it's leaving us. Okay, that's kind of cool and fun. So here we're looking at the configuration settings of output 1 on multi-viewer 1. Do we want the frame sync enabled? We can just turn our frame sync off. If we don't want to use a frame sync, frame syncs obviously take a little bit more delay than other things. You may not want to frame sync a monitor, right? You can manually freeze that output. Somebody asked, well, can I, if something goes, disconnected, loss of video, right? Can I get a freeze frame? Can I get a gray? Can I get a blue? Can I get a black? Yeah, you can get all those things right here. Freeze, gray color, blue, black. What is the status? So if this loses what's routed out what is it going to do? And there you go. You can also just manually freeze it. So wait a minute, all of a sudden I have 12 frame syncs that I can freeze an image on. That would have been really handy on some projects that I've been on in my life. I can tell you that one. I think one time somebody said they wanted like 12 or 10 frame syncs, and I was scratching my head in my production truck going, I don't know how I'm gonna freeze that many images. Well, this will do it right there. You can choose to lock it to the reference, or you can lock it to the input. That's up to you. You still have some timing and phase adjustments here, advanced and otherwise, to get things lined up the way you need them. But here's my favorite little things out here in the world. How am I gonna demo this one, ladies and gentlemen? Give me a second, because what I really, really like this portion of the product. This is those glue features that I kind of touched on. The ability to caption, put a caption. Now, this is not closed captioning. This is just a caption. This is just a name, a channel input name, an output name, or whatever I want to put on it and where I want to put it on the screen. If I wanted the upper left-hand portion of this to say, hello, it's now on. I've selected it as on. I've set the size to 3. So in the upper left-hand corner of this output of this system, I now have a caption going on. Now, let me, because this is the magic of webinar, right? Let me see if I can stop screen sharing for 2 seconds. Should all see my camera now, I do believe. And we see hello. For me, it's mirrored. Hopefully you all see it. And I'm going to cleverly move it around so that we can see that there is something there. So I can put whatever text I want there on the screen. I can put my channel input name, So wait, now I know what's routed there, so I can verify all my routes are correct, or maybe I can say, I don't quite know what's hitting that monitor. Oh, that's out 1. And it's the name that I've chosen to give it. But then the other thing that's really handy to do is maybe you need a logging position, right? All of a sudden you need a logger to know what time it is. Well, that's the next option down here. Let me start my screen sharing up again. Here we go. Hopefully you can all see the screen. And how I was putting the time code on was just the next box down here is just selecting it on. Okay. So little glue features built into there that just make your life a little bit better, a little bit handier. Here's your embedding. Here's how you can deal with some of your embedding. Let's say you're not quite sure. You just want it not present. You want to take that PID away, make those things not present. Okay, you can do that. You can say, hey, there's no audio. Well, why would I do that? Well, not present means it's on passing whatever's coming into it. Well, there's pass through. We can do direct pass through. Now there is a difference. Not present is actually stripping. We can see that it is stripping there, completely stripping the audio. Pass through, just on passes. Embedding, well, that's what we were doing earlier. Do we want to build in our own audio, and where would we take that audio from? Let me scoot back over here to the System Explorer, and that's where we'd route stuff. So we can see over here that we have a de-embedder, and maybe we want to reshuffle our audio. Maybe we don't want channel 1 to be 1. We can just reshuffle that. And so 1 is no longer existent. Maybe we'll put 1 on 4. So we start moving our audios around and reshuffling them. Or let's say that I said, okay, well, you know what I'd really like to have is I'd like to take one of my MADI sources, and I'd like to take these 4 MADIs here, and I'd like to embed them over here. It's just really easy to deal with like that. Still just route your stuff around. Okay, important things to know here. There's an auto delay, but we can also delay our audio. Set our own audio delay. Oh, that's nice. It's kind of a nifty little feature here. Let's see, where do we go? Where do we stop? We're rolling. I've got time to kill. But we also have our gain settings. So we want, maybe our audio guy's mixing a little low, or maybe he's mixing a little hot, and we want to save him on the embed, or for say somebody wants it a little bit quieter, transmission wants it a little quieter, but Bob, is mixing his audio a little differently, we can actually just change that output here. Test signal, yay, we have tone. All we have is tone, but we have tone. So we can just ID our channels like that. Hey, do you hear tone? Okay, and we can mute those channels, just straight up mute. So the PID's still there, but we're actually just muting them. So a lot of different flexibilities in that audio output. And we can just set our output again. We can actually turn the video straight up off. There's just no video coming out. Leave it on, or we can put in a test pattern. There we go again. These are the test patterns that we talked about. We can choose which test patterns we're going to push out that. So let's turn our video back on so that we can see everything's restored and everybody's back in line there. All right. So that's a brief tour of the configuration window. I think we're still there. I think we're still going here. Okay, some handy tools inside of System Explorer. So we're back in System Explorer. You can show inputs. That's kind of cool. So if I just want to click show inputs here, what that's doing, if we watch down here where my mouse is, we're going to notice that the name changes. So we can see what's routed out those positions. So if I have any choice of what's actually connected there, just click this box and it's actually going to tell me. If I want to start searching my system, let's see, where's party at? Where's the party at? Here we go, just search, it'll show me where party's at, right? We can select by type. Right now I have all types selected. Let's kill all types and let's just say I only want to see videos. So now I can only deal with videos, okay? Best way to start routing your video around, only look at video. But then I wanted to add data. Let's add our data. Let's look at these data. This is this tunnels that we were talking about. So let's go back to show all. And so now we can go from our standard application and we have our Ethernet link tunnel. There's an Ethernet link tunnel sitting right there. And our tape rack. And we're gonna go to our Ethernet. So how do we route that? We just take it, drag it, done, connected. Okay, we can see that it's a bidirectional connection. I have not even touched on today, as of yet, the redundancy built into MeteorNet. Okay, so we've got these 10 gig links. To get 12 by 12 3G SDI, I know that it takes 4 links. That's just off the top of my head, but I've got 80 gigs of connectivity. So let's say I'm connecting 2 standards together and I connect them via 80 gigs. I am one redundant, right? I have full redundancy there. I could lose 4 links at any given time and I still have all my redundancy. But what I need to understand with the product is that I have to designate how important those routes are. See this little bluish box here? I can actually go in here and I can say, hey, this is my most important route ever. This is what's going to transmission. For Chasing the Cure, right? Chasing the Cure was the first show with the US MediorNet truck from Touring Video. And it was a live show on 2 different networks. It was very important that we used priorities in our routes. And we told them, who was non-important or no route priorities, okay? So we have no reroute. We have low, we have medium, and we have high. Obviously, high is the most important, medium the next one down, low, and then no reroute. Well, why am I doing that? Because setting those up gives the system some idea of when to reroute those signals. Now, what do you mean reroute those signals? If over the TDM network, we start losing fiber bandwidth, okay? If things start going down, let's go to our net. This is a perfect time to go in our net topography. This is our links. This is the 5 devices that we are talking about right here. And oh no, in the middle of a show, somebody's decided to pull a fiber, okay? But we were utilizing that bandwidth. without setting reroute priorities, well, it's going to do exactly what it's told to do. No reroute. But if we set those priorities, it's going to intelligently reroute things based on how important we have told the system those signals are, which is awesome, especially when I build out a system and I build it with overhead. When I built the production truck, I had, I think the first show was 1.5 gigs. All the signals were standard 1080i. And I believe we had 96 by 96 video on the stage. And I think we were doing that over 11 fibers. No, it was 21 fibers. 96 by 96 video on the stage. That's a lot of video to do over 20, I think it's 21 fibers. If one of my guys is on, maybe they'll correct me, but it's been a time. But why am I going on this tangent? It's simple. You know, if that stage box out there in the middle of nowhere, right, lost something, it just would dynamically reroute and find a different way back around if it could. Obviously, there's not always a path back, and you can see that dotted line, and we lose two devices because I've got them out there. But if you intelligently design your system with a ring, and you can ring things out in the field, that's not a problem. They only have to go to the truck and then go back into the field, or maybe they just connect to two different devices in the facility or in the truck. Then when the system starts dynamically rerouting things, you don't lose anything. And that's really important in the middle of these live shows. And trust me, this system's gonna find a bad cable quicker than you can. Just watching that net topography, right? You can see how quickly when I pull something out, things just go down. It's like, I can't get there anymore, right? And things disappear. So that's another little trick tidbit that you need to know here inside of System Explorer, is making sure that you set those reroute priorities on everything inside of the system. And you know, MeteorWorks is just so easy to click through. I showed you that you can click here. That brings up System Explorer. All I've been doing to bring up configuration is just clicking on one of those outputs or one of those inputs, and it just brings up the configuration window. But if I wanted the configuration window, well, I can bring up the configuration window just by clicking the configuration here in the main window. If I wanted to know what my connections look like, these are the things that I've actually connected here in the system. I can see them all. Okay, and I wanted to know how they're bouncing around the system, how many hops. Well, there it is. I can actually just start clicking on them and seeing where they're going. So this is also another great place to go in and set your priorities. There's also a place where you can, again, you have the same features and tools that you can start narrowing things down. So I only want to see my video, or I only want to see my data. I can only see those things. Now, if I want to lock something in, I want to say that this is where I want it to be, right? And I don't want it to be rerouted, or, you know, I don't want to route. Priorities are the reroute priorities, but I don't want somebody to change that route. It's very important to me. I'll lock it. Simple checkbox, lock it. It is possible to see things that are disconnected. Right now we have nothing that's disconnected. That's the filter here to see disconnected. Just clicking through here, we can see what things are, how many hops they are, where they're located. So this is everything that we have, quote unquote, routed currently inside of the system. We can create a snapshot from that. We can also delete all of our routes if we wanted to. Because we have an IP Micron in the system, we can see the IP. Unfortunately, I do not have a 10 gig switch with me in 2110 video, but you know, that's the times. Unfortunately, if most of my product hadn't been at everybody's houses, this might have been easier to build up a little bit of a kit here for this. But this is what we got going on. If we had multiple nets, we could see multiple nets. At this point in time, that's kind of like, I want to show you what a working system looks like, right? This is a working system. So the next thing I want to do is break the system. And I don't want to start from scratch because I always love starting from scratch. It's kind of a fun thing to do. But before we get there, how about we take a moment and I'm going to stop my screen sharing and see if we have any questions right now.
Sure. Is there anything, how do you do remote workflows, like connecting the nodes together or multiple people editing the software? What protection is provided for that?
Inside of the software, let's go back in there. There is a way to set up user rights, logins, right? So you can have different levels of users built into there. Users is, it's not hard to set up. It's just, let's see if somebody's
And
logged this.
any editing that one user does is reflected at the same time for the other user if they happen to be looking at the same screen.
Yes, all routes, because this is a live configuration tool here.
Right.
So,
how many exits can be enabled in ASI? In other words, can ASI be routed to a lot of different outputs, even though it's ASI?
Yeah, not a problem. You've always been able to route
That
ASI.
because the input is a frame sync to start with and synchronizes, or what?
ASI, you wouldn't be running through a frame synchronizer.
Yeah.
Because ASI is a, it's basically a
Serial,
encapsulated compression.
Right.
Right.
Presumably,
rarely running ASI anymore.
You can pre-program your writing your system offline. I said no.
No.
Yeah, it's just like Dante and HelixNet and FreeSpeak. You've got to be connected to the hardware.
You've got to be connected. So, what other questions do we have right now?
Can the bandwidth of the ports be added into one? In other words, if I take two 40 gig sources, can I mix them together, and what do I end up with? Another 40 gig?
So that's going to be on really when we start talking about the TDM network and the calculations, because you use what you use. If you remember in the early slides, it talked about how, I talked about how it is what it is, essentially. Like we don't divide a 3G signal between multiple links, right? One 3G signal has to go down one link.
Right.
But that's not to say that you couldn't have 40 to 80 or gigs between two devices. You can have that, and it'll dynamically use the bandwidth the way it needs to use it. We'll look again a little bit later here. I'm going to get into the.
Okay. When you use mirror, can you route something to that output also?
It's tied up. You're tying up that resource.
It's only going to do the mirror. It's only going to do the mirror.
Yeah, it's only going to do the mirror.
Okay. Does the freeze frame hold the last source it had, even if you power down? Like if you did put something on
power it back, it will not have it when you power back up.
You won't have it.
No.
Okay.
No, you will not.
Does the function caption only work on an output of multi-viewer, or does it work on any video output?
It works on any Micron or any output in the system.
Okay. And the last question is again about bandwidth calculations, which we haven't gotten into.
Yeah, we haven't gotten into that one yet. We'll get into this. And I think you guys shared in the handouts, there is the Excel. So it's the Riedel MediorNet TSL calculator. that's going to be a really important thing for people to download and understand, especially when we get to that point in time. I'd honestly recommend, if you're watching the PowerPoint or this presentation, that you have that available and downloaded, so that when we get to that, you can understand exactly what I'm doing and follow along. All right, with no further ado, let's get back to my screen here. Sharing, start. So I promised the next thing that we would do was we're going to break this working system behind me. Let's do that. It's really simple. Not always are you so lucky to come into a brand new system that's configured. Sometimes you're going to walk in and you're going to see something that has no configuration. So to follow along the play-by-play is we're going to go into management. We're going to go into nets. Once we're inside of nets, I'm going to break it. Just so you know that how we can break things, we'll just deal with this real quick here. Selecting one of the units on the left, there's disassociated frames on the right. If I wanted to disassociate a frame, disassociating is different than removing. Let's say that I was going to replace a unit, and we'll do that with this Micron here. Let's just say disassociate frame. The frame shows up as missing, all right? It is a missing frame. That allows us to take another frame, be it the identical frame, the original frame, or one of the same type running the same application, and we can replace it, okay? So now we've replaced it. So what does that allow us to do? When something goes wrong, say let's something went wrong with our Micron here. We don't want to be destructive to our naming. We just want to disassociate it. So let's just disassociate it. So that way when I take and put in the new unit that I've gotten, I can swap these two out and hit replace. It's that simple to replace a unit when it goes bad. Other than the physical cabling that you will be tasked with doing inside of the software, that's all you have to do. Now, we can be destructive. We can say remove from net. And that's going to tell you, hey, you're about to do something bad. And let's do that. Oh no, everything just got mad because I completely removed something from my net, as you can see. And then my system changed. Obviously, my system changed. I completely removed a device from it. Okay, I can always add. I can click the net itself, click the device, and I can add. So I can, at any point in time, say, you know what, my system isn't big enough. I need more. I can go call my local sales representative from Riedel and buy another device and add it. Of course, you'll have to go in and you'll have to go into System Explorer and do all your naming constructs, and you'll have to figure out how you're going to put it into the TDM network, but you can always add a new device as long as you have enough bandwidth, enough cages. But for this, all intents and purposes, I'm going to be completely destructive. I'm going to take everybody over here and I'm going to say remove from net. Yes, I'm absolutely certain. I am certified I can do this. So I have no nets. This is what you'll see when you have no nets. When you load MeteorWorks, you're going to see undefined. Net space 0. Nothing. Nothing's going on here. We click on that undefined. It's going to bring up net configs because it's really nice to us. Like I said earlier, several ways to do anything. Double clicking on an undefined net will bring up our net configuration window because MeteorWorks knows you need to do something with net configuration. But if you want to get it to that in another way, you can go management again. You can go into nets. Select all my devices here. Well, you know, let's be tricky. I'm going to select 4 of my devices and I'm going to create a net. Net 1. We're going to say demo 1. So we'll name it. So we give it an ID, we name it. We get to choose a color. I love Riedel red. I just don't love seeing a lot of red in my system. So in this time, we're going to choose white because it just, you know, less alerting to the normal people out there in the world. Now we're gonna take this other unit that I have over here. And because I haven't chose an existing net, okay, I could have only created a net. Add only shows up when I choose a net when I'm in the net configuration window. But let's say that I'm over here, I've chosen this and I just want to create a net because I want to show you guys that you can have multiple nets here inside of the system. This is going to be my specific net. I'm going to make it blue. And so now I have 2 nets inside of the system. I can actually deal with 2 separate nets. How's that going to appear in the net topography? Well, wait a minute, there's no connection between them, so they don't talk to each other. So you can manage 2 separate nets inside of the system, just as long as they're on the same network and can be touched by the same computer. So, you know, let's say your company is hit with, you know, COVID-19 and you need to log in to multiple sites through VPNs and control multiple nets. You could do that. Not that that would happen or anything. Too soon. Let's remove this device from the net. It'll be the last one. And for the last time, we will add this to the net. So that's our overview of net configuration and how you configure a net. So now that I've configured a net, well, now I need to start naming things. I can go in here and I can double click, go in here and click. My computer's not playing ball today. But I'm in 1 in the configuration window. So let's just name this standard 1. We'll go into 2. We'll see that that's our multi-viewer. So we'd like to name that MV for multi-viewer so that we have an idea what it is. We'll click here. Oh, look, 3 is our compact. There we go. 202, well, let's see. 202 is our IP gateway. IP, perfect. And our last one is our other standard. And if we, standard 2, all right. It should be noted at this point in time that it's, you know, you're in the configuration window. We can click at the top of the tree. It's just like anything else, right? And this is where the name is, but we can give it a short name. We can give it a location. So these are other things, other pieces of information that we can put inside of here. Put who's administrating it. We can change the OLED screen on the front to be read-only mode. My favorite little portion down here is notes. We can add notes to devices, and I urge people, like if you think that there's something going bad, let's say somebody has abused this poor little Micron, then maybe you put in there, you know, you put in there in 1 bad question mark. This will stay in the device until somebody deletes it. Power it down, power it back up. The notes will always stay with the device. It's really nice. So you can start putting notes inside of the device saying this, that, or the other thing, what's going on inside of there. You can see the status of the device, product date, service date, all the kind of run times, all information, general settings. Oh, and if you know you're operating in an environment where you don't want the LEDs to be bright, well, you can just dim them completely out so the device looks like it's off. I would never go that low just because it makes the device look like it's off. So you know, that's configuration of the overall Micron itself, and that's how we just built out a net. Again, we can go in, we can start naming things, and now's a great time to just say, hey, I want to right click on this, I want to say rename, and all of these are going to be cams. So if you notice, it automatically gave me my numbers from 1 to 12, right? And I can do any portion of it inside of here. Excuse me. Click happy today. Right click, rename, and we'll say Joe W. 1 through 4, just because I want to give them a shout out. There we go. That's how easy it is to name things. You can do the same things with the embedders, de-embedders as well, if you want to just select multiples inside of here. Through 5. So really easy to name the product, you know, inside of the configuration tool and build our system. And there we go. We've destroyed the system and we've built it completely back up. We can now go in and start making our routes. We do not need the name to make our routes, by the way. The names that obviously come with it are more than enough for you to start making routes with without a problem. But we need to go in here and we need to find our active videos again. There's an active video, so let's route that out. And so now we start building up the things behind me, which is really nice. And I had a multi-viewer, so let's go ahead and go to the multi-viewer. And I'm gonna go ahead and put the multi-viewer out, multi-viewer 1. Again, it does not have to come out of the multi-viewer video outputs, but that is just where I have chosen to put it for today. Oh, but I haven't routed anything to my pips. So let's route some things to my pips here. We're gonna go, and this is how you route video to your pips of your multi-viewer. So if you're curious about the multi-viewer routing of the pips, just pay attention right here. We're gonna select the multi-viewer down here under our destination. We're gonna select the multi-viewer, which pip, you know, which window we're gonna be dealing with, and the pips, okay, 1 through 18. You'll see 1 through 18 on all of them, but you need to delegate which ones you're going to be using just by routing things into them and logically using what you use. You could route to everything, but you can't use them, and we'll see that when we build things in the builder. Videos are plugged into my standard one, hopefully. Nope, I've got them split up here. So pip 1, go to multi-viewer, go to input. Things changed when I changed them. So now we've added things to the window behind me. And so if we stop sharing screen real quick and you see my camera again, I've routed things back into there. And if I wanted to, I could delete that connection and you'll see it go away in the bottom right-hand corner. We'll bring that back in. This will probably be a duplicate of exactly what's going on there. Let's go find our party footage, which is on input 1, and we'll bring that back down here. And there we go. We've rebuilt the multi-viewer again. All right, so started screen sharing again. Here we go. But you know what? Let's build that multi-viewer. I think now it's nice to know that, you know, it's quite simple to build a system, right? But how do we build a multi-viewer? Operation multi-viewer. Here we go. Here is our configuration for the multi-viewer. Let's see what configurations are already there. We'll double click on one. Do you really want to discard the changes? It's asking me, do I want to discard what's in the editor window here? Yes, I do, and there we go. So let's make this a real graphical use so that we all know that I've done something here in our TV Magic land. We're gonna move pip 2 there. We're gonna move pip 1 there. And if we apply locally, I got to see a change, but you did. Hold on, let's see that. So we made those changes. We've moved some things around. We've made it dynamic. And there we go. Things changed here. One more time, I'm gonna move some things on the canvas while you guys are watching the screen, and I'm gonna apply locally, and things have moved around again. My least favorite multi-viewer I've ever made, right there, as far as the way it looks. So I'm gonna change this back around one more time so that we know that things are actually happening and it's not just the magic of webinar. I'd say the magic of television, but you know, not much of that's happening. So that's an easy, simplistic way of moving things around inside of the multi-viewer. You've got other, layouts for each one of your heads. You have a net wide configuration. That's what we talked about earlier. Right now we have no net wide configurations built. Let's actually build one real quick here. We see which type of screen. We're just going to build through here and say, right now our screen is in landscape. We could decide that it would be in portrait. Let's not do it portrait, but I want a background color. Let's go Riedel red again. Thresholds of our meters, colors of our meters or tally indicators, our embedded audio source. So if I turned up the television behind me, you would actually be hearing the audio from PIP1. When you route a multi-viewer to a destination, it will route with the audio associated with that PIP, okay? So I could hear the audio from PIP1 right now, which is nice, or any one of the PIPs as long as I programmed it as such. All right, so let's choose a layout. Quad box is always nice. You say, wait a minute, there's nothing in there. And I've got customs if I wanted to save my own customs, but this is a quad, typical template. And then I choose, well, what do I want the pips inside of there to look like? I'll choose one of them. This one looks just fine and dandy. Maybe I'll change it to this one because I want to change it. Okay, we can bounce between them. I like the way that one looks. Maybe those are a little thin on them. I want a bigger UMD. Okay, and just by clicking, it automatically changes everything inside of there. No audio. Now this is an audio class. Let's go with something with audio in there. We have widgets that we can put in there. We talked about, pips are pips, right? Those are the things we kind of already built in, but we could put in another pip if we wanted to. Let's not. Let's delete that tile. All right, but maybe we want a clock. We'll put in a clock there. We'll give the clock some room. Okay, good way to give the clock some room. If we had an image that we wanted to put in, we could put in an image. Delete. Unfortunately, I don't have any images with me right here. Let's see if I can make one. Typically, we can take in JPEGs. Going a little off book here. So we've added a little image here to the multi-viewer screen. It was that easy. I just dragged it on from my my desktop. That's just a part of my background that I just did a screen capture on. I could add UMDs if I wanted to add another UMD, which is under monitor display. Could go in there and edit the properties of that one and say, hello class. So okay, there we go. Gotta hit enter afterwards. My bad. So now we've made all these changes to the multi-viewer, and we just apply that locally to that multi-viewer. We could decide to save layout. Right, so we've saved it locally. We can save it to the system. Let's say this one's we're gonna name it hello class. And there we go. So hello class now shows up net wide. I can apply it to any multi-viewer in the system. If we wanted to actually see this one here, let's just go there. And apply hello class to multi-viewer 1. So we'll do that. Ooh, I like that. And just to show you what we've done here, let's go ahead and stop this again. And you can see that we did our hello class, our clock, our image, all those things just showed up here on the multi-viewer behind me because of those changes that I made inside of the system. So we'll go back into our software and I'll rearrange my windows again. Here we go. That's how easy it is to do multi-viewers inside of MeteorNet. Meteor works. I think it's quite simple, quite easy to deal with. Some more advanced features in there that we could get to, but not really that pertinent to the class. Again, I built it and I didn't accept all the links. These are the links because all the links were new when we built a brand new system, right? We'll just accept all of that and we'll be happy there. So we've covered System Explorer, we've covered our configuration window, you know, we started looking connections. These are all of our connections that we've made, and we talked about prioritizing the connections, and we talked about how to see where the different hops were with the connections. We haven't looked at our matrix view. Matrix view is nice, it's saved locally to the computer here, but I could actually just use this to route things. If I didn't like the drag and drop and I wanted the old pin drop features of some older style routers. And this is stuff you can make yourself. You can make a group editor. Inside of group editors, you can start grouping things. Let's say you wanted to group your videos, and we can just add those. We're going to select a new group and class. Okay, and those were inputs, so we're going to need outputs. Boom. And so we've made a new group here. This is group editor. Group editor works in tandem with the matrix. And so when we drop this down and we say class, now we have our inputs for class. And if we want to change our outputs to class, then we have our inputs and outputs from class, and we can just double click and route things. So that's another easy way, fun way to start routing things. And you can actually, if you wanted to, start dialing in inside of your class in one, you know, those kind of things. Things with one. So that's the matrix view, the routing inside of the matrix view. Frame synchronizer, you would think that that'd be frame synchronizing, but no, this is actually how you select your sync input on the system here. You can see that everybody's slave, this is master. If you have your sync, if you want to sync output, you can set your sync outputs. This is really handy and really cool to me, being somebody that used to work a lot in the field and deal with a lot of wild sources or people that I would have to give sync to out there in the field. Anywhere I put a Micron, I have a sync output. Not only have a sync output, but I have two sync outputs, because if I'm not using the input on the Micron, it becomes an output. It's a mirrored output of what I've set right here as the output. It's kind of cool. So if I wanted to give somebody Blackburst NTSC, well, there it is. Tell them up, ring them up, say, hey, you have Blackburst coming out of the sync output of that Micron right there. Please plug that in. Let me know everything locked up, everything's good. And, well, I don't really need it because I could just use the frame synchronizers inside of the system, but I still have it as an option, right? If I wanted to give tri-level out, I've got all my tri-level options, 720, 1080i, 1080p, 1080p SF, all those things work inside of there as tri-level output. Word clock, what do I want to give out? Oh my gosh, for you audio guys, you want to clock your audio console out there. And you don't have to have, this isn't a route, okay? This is actually putting out this sync standard in time from the MeteorNet system. This is now a sync distribution system, right? I've already told you that the TDM network syncs everything, and everything in the TDM network is synced, right? Now I have the ability to give different types of sync to other devices out there in the world, out of my Micron, okay? So anywhere that I can hook up my Microns and set everything, you know, up to, I can get a sync output out of in my choice, and my choices are Blackburst, tri-level, word clock, right? Those are good options to have, at least in my opinion. You can also set a sync source. Right now, I'm just going to tell everybody that they don't have any, because they don't have any. And if this is set to none and this is set to something, well, now I know that my sync input is actually a Blackburst output. We have sync priorities. We have a master, secondary master, tritary master, the third master. Okay, so things can start failing over. You know, if for some reason your Microns had problems or you had link problems or those kind of things, you can now start telling devices where to look for sync, you know. So that's the frame sync window. Net topography, we were already kind of dealing with net topography. I like net topography a lot because I can see what's going on inside of my net. and how the health of my fiber is. The really cool thing is, so I can build my own layout, right? And then I can save my layout. Once I've saved my layout, okay, if I go out of it and I go back into it, my net's exactly the same. Interestingly enough, I can apply a picture to the background. So let's apply all. It's going to be really, maybe hard to see. So we'll put some of these way up here in the sky, and we'll put a Micron down there in the valley. Let's say I'm doing a mountain biking event and I want everybody to know where everything is. So this one's over here on this hill and this one's over here, just an extreme crazy example of what you could do right there. But another thing that I did with the production truck is we literally go into Paint every time they do a show, and we make a new Paint background for this little box that says maybe production truck over here, and we put all the production truck nodes inside of the production truck, and we put the ones out on the stage where they exist. So that way we know how everybody is connected up, and we can see in an instant, where these devices are just by adding a picture to the background. And if you didn't see that, all I did was just click a photo from my desktop and dropped it in, and I can tell it, what do I want to do? Do I want to fit to the window? Let's not fit to the window. I can apply to all. I can apply to just this topography window. So I can save it inside of the system, or I can just make it local to myself. So now I've got the ability to start, laying these things out, making net topography a little bit more of an active map. It didn't save because I didn't tell it to save. Somebody's at home looking at it going, it didn't save. Yes, I didn't save. So let's save layout. Let's prove that it works. We'll hit that topography again, and there we go. Kind of a fun way to run the system. Live monitor, what's going on in the system? We've got this MADI. This MADI still becoming an issue, but of course this MADI is an issue because it doesn't have sync going into the artist frame, and that is coming out of the artist frame right now. I just don't have it set in. So logging, logs, what we have set to log, right? Right now, we're not logging anything. Now, just a brief overview. I've got to think, what have I not shown you guys today? Is there any questions? Let's open it up again to questions real quick.
Yeah, there's a couple. When you rename a device in or out, do the labels on the roots follow automatically, unlike Dante? I think what he's referring to is when you label an input and output on Dante, it doesn't propagate to the device you're connected to. And I think that's true of MeteorNet as well. Changing a label in MeteorNet does not change the input name of the device you're connected to on the device.
Yeah, that's correct. If you think of it that way, you could use a third-party server, and if you were to use a third-party control system, when you made changes in there, it would change in MeteorNet and it would change in the device. But as far as actually telling the video switcher, MeteorNet does not tell like a video switcher what input it's now routing to it. That would be a third-party control system.
So if you have to label in your media switcher, label the outputs, and then in MeteorNet, label those inputs or whatever to match it if you wanted to.
Yes.
Right.
Unless you were using a third-party control system.
Okay, like who?
Hi. The
Okay.
touring video truck uses Hi right now, and I know that their switcher integration on Hi is set up so that now when you change a name inside of the control system, it changes in MeteorNet and it changes in the switcher, the video switcher. So now when they make a route, it tells the switcher what's routed to it now.
Is that a product that comes with the switcher, or they sell it with the switcher? Is that the deal, or is that another third-party company?
It's a third-party control system. It is a separate control system, like VSM from Lavo does similar things, right? This is that overarching control system that a lot of companies are now going to here in the States. It's pretty common practice in other places in the world, but we're just kind of coming around to third-party control systems out there.
If I substitute a duplicate piece of hardware, will it assume the program that was for the piece I took out?
Yes, if you do how it was demonstrated here, nets, right?
Right.
So if we're inside a net config and we had another let's say this standard Micron here was bad, or we just needed it on another show and we didn't have it. So we disassociated it from, let's say, our production truck, and then we brought in a different device, completely different device, different serial number, the like. We could select the two and we could click replace, and it would assume those names that we had already put into the system.
And all the routes would work to it and everything. So nothing really
Yep.
changes there.
Nothing changes.
And then can the matrix view be programmed offline since it's in your computer?
No, you can't do the group edits offline.
So, but you did say the
Actually, take it
matrix
offline,
view
man.
only exists in the computer.
Then these,
But when it's connected to
it's the groups. The groups are existing here because you know, Dylan is actually the name of the EIC, or was the EIC on the production truck. So that follows, that's a local file here, but that's the groups. To get more definitive, that's the group names. But you do need to be connected. As you can see, the system just came back online because I disconnected it to just say, yep.
And can the system lock to a PTP 1588?
If you have the IP bridge application, yes.
Okay. Can you save your matrix crosspoint, as I said before, in the computer? Can you save it and reload it? If I had a matrix configured for this particular equipment for one show and made a new matrix for another show, I could save it and reload it.
That would be load and save configurations. I have a bunch here, but
So it wouldn't be specifically for as the matrix, it would be the whole config.
It'd be the entire configuration, including the routes.
Right, okay.
Everything is saved here in configuration.
Okay, and how do you integrate UMD Tallyman to MeteorNet?
That's third-party control systems. Third-party control system, under management, you'll find third-party control system. You have to reveal IDs for all of these.
Yeah.
Which will relate to the IDs. So let's edit selected IDs. I'm just going to do a bunch here. So I've just selected all, and I say edit selected IDs. And so now it's given all of those. I'm going to apply that. So now I'm exposing all of these in TSL.
To the program that does the tally.
Yep. And if I want to do ProBell, I can select ProBell. If I want to do Ember Plus, I can do both of those at the same time, and I'll set them out. I'll need to set a master, one of the devices inside of the system, and also a second, you know, you can have the secondary master, which is obviously another device in the system in case the first one no longer is communicating for whatever reason, network failure, cable failure, talking to the system. But that's part of the whole third-party control system. Tally systems are kind of in that realm of third-party control systems where, you know, they're controlling us and, you know, telling us IDs and names and those kind of things. So you just reveal them here. You need to reveal the inputs. You'll need to reveal the outputs, give them all numbers. They don't have to be sequential. It's up to you what you want to do, how you want to number those.
Back to the question about, follow up on the question about, I guess about substituting a piece of equipment, which you said the routes and everything will stay the way they are. which he's pointing out in Dante, you change a piece of hardware and the serial number changes and you lose your subscription, which that doesn't apply to this because the individual piece of hardware don't have a unique subscription hard coded into them.
No,
right?
you can do that. You can load your configuration and everything will go back. Yeah.
Can you put your PA system control network or your VDO wall control protocol into your MeteorNet? That would just be using a tunnel between points.
If it's IP and it can pass over a network switch infrastructure, yeah, yes, you can.
Right. But again, that's using a tunnel. It's not any of the switches involved on either end. It's just a single in to single out bidirectional. Yeah. Right. Can I save this whole configuration on a USB, or does it only exist in the devices as programmed?
You can load and save your configurations under management. Load save configurations. Name it.
Right. Okay. And if you load a configuration, it will display all of the devices. But if you're missing a device, it will indicate that it's missing. Mm-hmm. Right.
Yeah.
Okay. And does the Ethernet port carry tags for Cisco Vlan assignments?
Yes.
Because it's basically transmitting whatever kind of Ethernet you put in, any flavor goes in and out. Okay, that's all we have right now.
It'll transport the tagging without a problem.
Right.
129 something people, and that's all the questions we're getting. I mean, I'm either answering everybody or they're asleep.
I'm making up half of them myself, so it's okay.
Hey, like I said, I mean, they're either asleep or doing a good job. I don't know which. Here we go. So trunking is also possible inside of the MeteorNet system. You can do dynamic trunking between MeteorNet systems. You just need to configure it properly, obviously. Like anything, you just need to say, hey, this is going from here to here, create trunk. Right now, I don't have two separate nets, so I can't actually create trunks because it knows, hey, I can already get there. But if I had two separate nets, we could create a trunk inside of the trunks. And what's that mean for you? Well, you know, now you can route from one net to another net. You will have to physically connect the two over baseband. There are minimal cases where you might want to do that. I know some people like to have this like overarching network where they've connected all of their theaters and all of their theaters have Meteor nets. So they just use that dynamic trunking to go between the theaters. Date and time. How do we set our date and time? There we go, date and time. Right now it's set to internal system. I could set to an NTP server if I wanted to. If I had that out there, I could sync to timecode source. I can also free run and just apply those things. It's at this point in time, I kind of tell you how you can also bring LTC into the system. It's important to note that LTC is going to come in as an audio stream, either from your MADI. Let's say it was on MADI 1. We're going to go to the main module here. So if any one of these devices, if I go to the main module, main module, there's LTC. Okay. So however I bring audio, choose to bring audio into the system, I route that audio because timecode's audio, route that over from anywhere in the system to the devices. I can start, you know, setting up my LTC, and you see that we already have LTC set up. Okay, so there's that. That's time and date test patterns. You want your own test patterns? You can bring your own test patterns. Riedel, we have our own test patterns built into the system. You can have them on each individual unit can have a different test pattern. I know that, oh look, there it is. Some people like to build their own test patterns, as you can see here. And Pacific Broadcast has nicely supplied me with these test patterns inside of these units. So they might have just put their logo over ours. All right, but it's that easy. You can just do that as long as it's 720, you know, by 1280, you can just drag and drop it in here like we were doing other images. And per unit, just set them up so that you have your own test pattern. I've also seen people like to use the test pattern as a waiting slate for their webcast, right? I've seen that. Somebody put the logo in there instead of an actual test pattern. And so then they're sitting there and they say, okay, multi-viewer 1 output. And we're just going to put this into 1080i 50. And all of a sudden, the big bright image behind me, if I stop sharing, whoop, we have a test pattern. But you can put your own in there. So that's up to you. Start screen sharing again. All right. Every time I do that, I've got to rearrange windows. Now, so that's test patterns. Third-party interfaces, we went through that. SNMP traps, you can set your own SNMP traps and see what's going on with the units. Okay, it's your choice to activate them, the SNMP. There's documentation on that. If you have more information, we can, get at that later. Matrix signal groups, we dealt with that. This is literally the window that we saw. We were in the matrix. There are a bunch of different ways to get there. That's group editor. It is the same way to get to group editor. And that's how you make those groups to route inside of the matrix. Snapshots. Do I want a snapshot of what's going on with the system? And we can load different snapshots there. Go into snapshots, but and we were already in load save configurations. You can see that I have a bunch of different configurations saved inside of here right now. System Explorer, we've gone over. Here, again, it's kind of fun. These boxes here are under the operations tab as well. You get to all those same things. The counters, we talked about the counters. How would we trigger counters? Counters can be triggered through MeteorNet control app. I'm not going to cover that today. We have MeteorNet control app, which can run on our 2318 panels. It's an application.
I hate to bring up an old subject, but we really haven't covered the calculator.
We're going to get there.
Okay. We got 2 minutes. There we go.
All right, 2 minutes.
We have as much time as you want, Jeff.
Oh, yeah.
I thought we went till 3. I thought I thought you were
plenty of
3
time.
to 5, but we can go as long as you want.
We got plenty of time.
Hey, you tell me I get out of here early, I'd be happy. But
there you go. We still got stuff to cover.
I was planning on a 3-hour course today.
There you
if
go.
we still have people logged on, I'll keep going. You tell me
do.
how many people are logged on.
Go for it.
All right, here we go, guys. You know what? Let's get out of MediaWorks today. Let's be done with that. Let's get into PowerPoint presentation because that starts dragging, and we'll get into. Let's stop this for a second so that we can properly get into our PowerPoint presentation. Okay. People are gonna love this first slide. PowerPoint presentation. There we go. Come on. Well, we're gonna full screen this. We're gonna fly by the wire. Okay, back to the basics. Everybody's got to think about non-blocking versus blocking, and that's something we're really going to get into with 2110, right? What is blocking? What is a theoretically non-blocking system? That's the ability for, all 312 million people in the UK to be able to call everybody in the United States. That's theoretically non-blocking. That means everybody at any point in time can pick up a line, and everybody simultaneously can call all their friends and neighbors in the US. That does not make a lot of sense. It's not going to happen. No one's ever going to do it. It's not cost efficient, right? We just don't have it out there. But you would expect it to be partially non-blocking, right? So X amount of people in Europe can call the US and vice versa. And that's what, you know, partially non-blocking is. That's what the theory, you know, comes from, is it really non-blocking? So we're really gonna think about what is blocking, what isn't really blocking, and how we're gonna use this system. Do I need the ability to route every single input in my production truck onto the stage simultaneously? Well, gosh, no, I don't. Okay, it's just never gonna happen. So we have to design in a safety margin and allow for everything that we think is going to happen, but not be ridiculous. Your telecom systems out there operate on islands. We can have these different islands, and then we have to figure out what we're going to share between the islands. I have a MeteorNet project that I'm working on right now. We have multiple theaters around this facility, and the theaters are going to do their own little shows, but every once in a while, somebody's going to come in and they're going to want to share signals between the theaters. Well, how many signals are we going to share between the theaters realistically? Well, there's one screen to all of the theaters, and none of the theaters have production equipment, so there's only really possibility of really truly sharing possibly one screen to all of the other venues. Because what are they going to want to see? They're going to want to see the presentation. Okay. So they operate on islands. What do we want to get between these islands? Those are the things we have to start thinking about, right? And how do we split things up? Excuse me, I got something here. So we got to start planning our decentralization of our router, you know, and moving it from the truck to studio and all these glue features and all these kind of things that we can get out of this. Oh, come on. There we go. So how many different islands do we think we're going to need, right? What needs to get from where? You know, all of our cameras need to get from the CCU rack to the tape rack, and they also need to get to the switcher rack. So how are we going to start cutting these things up? What are these islands going to look like, and who needs to go where, and identify our signals and sources, what types they are, how big they are, locations, functions. And then we got to start calculating this stuff. Let's calculate the bandwidth, the real world case scenarios, you know, and figure out how to make this non-blocking scenario become a blocking scenario that we can deal with, you know, the theoretically non-blocking become practically non-blocking. What works? Okay, so redundancy. We talked about redundancy a little bit today, and we got to think about those redundancies. You know, do we want, okay, if I need 4 links to get all 12 by 12 3G signals from point A to point B, do I really need 4 additional links? Is it logically possible that I'm going to lose all 4 of those links? Probably not. It's more likely that I'll lose 1 of those links or 2 of those links. So maybe I get redundant with 2 links, you know? There's no single point of failure. We know all of this stuff inside of MeteorNet. And so we just have to build in our redundancy over the fiber network, and we can control and look at everything over SNMP, automatic seamless switching between, you know, up to 3 sync master frames. And so we have all these different, you know, redundancy topics that we can get into there. And no, this isn't redundant. Putting, you know, signal into both is not redundant, but we have to locate our redundancy, our power, spread it around, our port redundancy and those kind of things, and really think out all of our bandwidth. Are we redundant with one big central core frame that could just get rained on at any point in time? Well, the answer is no, but if I move microns around, right, I could, you know, lose one piece of equipment, which is not this monolithic router over here on the right, and still keep going. So some examples of different setups here. We put in 4 Metrons so that we're sharing the bandwidth between all of these different devices. We have backups built into there, and we can lose this, you know, 1 or 2 Metrons in the system and still have a fully functioning system. External control room connected, all Microns are connected. And up to the 3 syncs. Can we do 4K? Yeah, we can do 4K. There are 2 formats possible, which UHD quad link signals right now, square division and 2SI. We can do that, okay? Quad links, on the left, you're dealing with the, well, actually that's square division. I'm sorry, I've been talking for a long time. Two sample interleave. I love two sample interleave. It's 2 pixels from the first line, 2 pixels from the second line, so on and so forth, onto the first line, second line, 2 pixels from the third line, 2 pixels from, well, it's actually the second line, start again at the second line, 2 pixels, 2 pixels, and that's how we divide it up. And then we can do both of these. That's the big thing here. The big takeaway is we can do both of those at this point in time. There we go. Cut everything up. Boom. But how do we plan a MeteorNet system? This is the biggest question we have right now. This is the bigger point that I'm trying to pound through with this presentation. It's how do we start? What do we start looking at? We need a diagram. We really need to start thinking out logically. What's going to go where? What our bandwidths are? What are our requirements? What can we do? I beg you, please start thinking about your MeteorNet system before you start deploying it. What do you need? Where do you need it? Because then we're going to start dealing with bandwidth calculations, right? We have to start dealing with what type of videos, what type of audios, speed of the Ethernet tunnels, number of types of GPIOs, available number of fibers. We have all these questions. Can we use AOC cables, active optical cables? Do we need WDM, CWDM? All the run-in power supplies for the compact frame required. What do we need? We just got to start thinking about all of these questions. And I don't want to scare you with questions, right? We've got like a nice simple form that you can fill out and start answering your questions. But if you don't ask your questions, you don't know which devices you need, which product you want to select. And by the way, don't let any of this scare you. Call us at any point in time. I'm a systems consultant with the company. One of my primary jobs here is to help people design these kind of systems out there in the world. So if you have questions, feel free to ring us up. I think they're going to, let's just say, my email is going to be put out there for everybody's edification if you have any questions following up on this presentation. But figure out your systems, how you're going to use it. Is it OB? Is it fly packs? It's a great thing to use between fly packs. And here's where I'm going to actually skip applications, and I'm going to go and I'm going to pull up our handy dandy. I said everybody should pull up this. This is our time slot calculator. So I told you, you got to start thinking about, well, how many videos am I going to move from point A to point B? Am I going to move 3G signals? Am I going to move 1 gigabit Ethernet tunnel? And am I going to move 2 of my MADIs? Okay, well, if it's a 4.25 gig link, I need 4 links. Ooh. But if I'm a 10G, okay, right here in the link, this blue link here, click down, we can change to a 10 gig. Compacts operate off of 4.25 gig links. There is up to 12 links inside of one unit. Microns, remember we said 80 gigs of connectivity. That's 10 gig 10 gig SFPs inside of that unit there. So we can do this inside of 1 micron, right? If we did 12, can we do 5 links? We can still do 5 links. That's good. So we add another link. We have a redundant link in there. We can add up to 3 redundant links there. 3 redundant links inside of that one to move 12 videos, 1 Ethernet, and 2 MADIs. Okay, so we start calculating what bandwidth we're going to use. Somebody had a question earlier. They said, I want to move 3 videos, 3 3G SDIs, and it's saying 2 links. Well, there it is, 2 links. Calculator says 2 links. That's how many you need to move it across. We also have a 1 gig Ethernet tunnel in there. Wait a minute, that's our problem. It's only 1. So you can just go through this form, which was shared here, right? And you can start
section. Yes, sir.
In the handout section. And thank you guys for putting that in there today. but you can start calculating how many links you need inside of your fiber system. Shoot, you guys did not tell me. Hold on, let's back up here. Are you guys seeing the Excel right now?
We are not. We're seeing the PowerPoint still. Sorry about that.
All right, it's fine. Let's see if we can get to the Excel.
There we go.
Thank you, Rick. So let's back up. So this is the Excel that has been handed out to everybody. And if you were playing along at home, which, you know, maybe you guys were playing along at home, you have a handy dandy choice of signal types that we can bring in and out of MeteorNet right now. You have this blue box here. If we click it, it is actually a drop down. You can choose between 4.25 gig links and 10 gig links. 10 gig links are the Microns. So here we go. 3 fibers, or sorry, 3 3G SDIs. And there we go. 1 link. We want to make it redundant. Guess what? We'd add a second link. So we have 1-for-1 redundancy right there. But let's say we were running 6 videos, 2 links. We can add 1 more link. We can run 3 links, and we have, you know, not 1-for-1, but we have redundancy built in there. So that's a quick overview of this Excel form. So just think through your system as you're building it and put in what signals you want and see how many SFP links you're going to need. Don't forget to change it from 10 gigs if you're going to use Micron or 4.25 gig links, and just kind of play with this. See what kind of bandwidth you need to actually move your video around, or audio or data, and you'll see that data takes up next to nothing.
Does this apply for ring topology as well as point-to-point, or any topology, this calculator?
Any topology, the TDM network, this is from A to B, right? The link calculator says from A to B. This is how much we need. So then you have to start doing the math. Let's say you had, if you had a ring, you could obviously split things. You know, if we had
some data goes one way, some data goes the other way.
Exactly. How many links do we have, and how much stuff do we have in between that have to go to the same places?
But the calculator, you always have to assume point to point.
Yes. This is how much is it going, how much bandwidth is it going to take up? But we can start doing some assumptions. Let's say that I'm going to pass 3G videos from A to B. So then I'll do an additive, right? So I know from A to B, I have 2 videos. I'm going to tack on 2 more videos, right? So now we're at 4 videos. So from A to B to C, we're at 4 videos. And now we need 2 links in that last destination, right? If we want to do a daisy chain. Does that make sense?
Yes, it does. But I guess if you're considering redundancy, you can't count on that circle link to be a viable path for your 6 3Gs. You have to have enough fibers going both directions.
Yeah, and you know, this is how to calculate the bare minimum of what you need, right? We're merely calculating the bare minimum of what you need here.
Would you suggest over linking, providing a lot more fiber than you really need just to cover yourself rather than trying to have to run something? Or if you know use this calculator to figure out what's the worst case I could have.
Yep. That. You could start doing a lot of math, or you could just fill up all the cages. And I'll tell you that. I try to, when I build a system, I build them as robust as I can. When I have there's 3 field boxes that go with the production truck that's running around. And each one of those has 1 micron in it. I think one of them now has 2 microns in it. but we will run from each one of those boxes 80 gigs back to the truck. There is no way from one Micron that we are going to fill up all 80 gigs. It's just not going to happen.
Do you use
Right.
bidirectional SFPs or not always double?
Well, that has to do with you and your budget. That's kind of a budget question. And
Right.
when I'm using stuff in the field for that production truck specifically, we chose to go with BiDi SFPs. Why? Less fiber strands.
Right.
Does it make a boat? Yeah, I mean, it does. It doesn't matter one way or the other because we're running TAC 12s to every box anyway.
So you get plenty of lines. You might as well plug them in as backup as long as they're going there.
Yeah, why not? Why not? 80 gigs is better than 40 gigs any day, right? And the system can dynamically allocate all of that, those things, and you don't have to worry about how it's going to distribute them. And don't worry, the overhead is not going to tax the system at all. Stop that screen sharing real quick here. But that's the calculator. That's the basics of the calculator and how to deal with the calculator. We have some more examples inside of this PowerPoint presentation. If I can get it back, cool. I think I got it back up. So you have choices when it comes to fiber connectivity. So you need to think about, do I want to run AOC cables? They're cheaper. Point-to-point cables, basically a built-in fiber. Okay, so you need to know the lengths. You need to know that you can run, X number of these things between the racks. You're not trying to go through any mouse holes, so we're not going to be able to get the SFP that's tethered to the end of this. This is not removable off of there, but much cheaper, still passing, up to 10 gigs there. Or, the duplexed LC connectors. So you got to start thinking about what kind of SFPs. And remember, I can't tell you how many times the math problem has come up for some reason. That you got to always count that you need a sending SFP and a receiving SFP. So you need one in either SFP cage on either piece of equipment.
Will the Excel be updated for 4K?
The Excel document, I anticipate being updated, but your 4K you can do because we know right now that it's quad link, right? 4 3Gs, so just put in 4 3Gs.
Okay.
In that placeholder, and you're there. So keep in mind the bandwidth is always bidirectional, right, when you're calculating those things. So if you want 4 videos in one direction and 3 videos in the other direction, let's deal with the higher number of 4. Oh, let's advance slides, okay. Estimator take care of, sorry, excuse me here. So Meteor has taken care of the final routing within the system. It's nearly impossible at the moment to foresee the full calculations and the needed bandwidth. Okay, these are just ideas that you need to think through and kind of overbuild. The following facts, are the final routing within MeteorNet. Number of hops from the source to the destination device. MeteorWorks tries to find the best paths with the least amount of hops. It's always going to try to do that on its own. The length of the fiber. MeteorNet always tries to use the shortest fibers first. Okay, how things are bouncing around. The long, light speed is light speed, but it's still a speed. It's still a denomination of time that we have to figure out how long it's going to take. So it's going to try to take the shortest path there at any point in time. So it can easily happen in a mesh network that a fiber link to a MeteorNet device is already occupied by using the device just as a hop between other devices, routing signals via stage box. So it strongly depends on which signal is routed first, okay? Who's routed first and how you route things.
Unless they have a higher priority.
even if they have a higher priority, the priorities come in when you start losing stuff, not when you're building stuff out.
Won't push something out. Okay.
Yeah. So, you know, think about how you stack your Metrons. You can put 2 10 gigs at the top, and then you're not going to be able to use the bottom two 4.25 gigs, or you can put one 10G SFP, and then beneath that you can put 3 4.25 gig SFPs. You can also just put 4 4.25 gigs in the stack there. So start thinking about how you're going to stack things inside of your Metron. This PDF is in the handout section if you guys want to get back into this and see more about what's going on inside of here. You know, what we support for, you know, number of signals right here, again, for the Micron, 12 SDs, 12 HDs, or 12 3Gs. You got to figure out what's possible on running the links. Your multi-viewer. Up to 18 sources can be used within a multi-viewer engine, so you have to think about this one. There's also the 4 additional IO SDI BNCs to be used. So start calculating out how many links when you start using a multi-viewer in and of itself, and what that bandwidth is going to mean for that, right? I always try to fill up my links when it comes to a multi-viewer, because this thing, if nothing else, think about it, is got the most possibility. It's got 18 possible videos coming into it as a destination, but you've also got 4 additional outputs coming out of the box. That's 22 videos versus the 12, right? So think about your bandwidth and how you're going to use it on the multi-viewer. So here's some examples of systems that are out there in the world. Required size 188 in, 269 out. Well, so we're going to have to go by that bigger number, 269, when we start counting everything up. Or divide by, 269 by 12, because we know the microns have 12. We're going to need 23 microns to achieve this video. And we start calculating out the links. I'm getting a little dry over here. I'm sorry. Give me 1 second. So you just got to start going through the process of calculating everything through. But let's get into the examples here. You can connect Metrons and connect your microns to the Metrons, and start thinking about all these different, ways. What's cheaper, what's, and I'm gonna say that this is a customer facing presentation, but always deal with us for pricing and request pricing. This is a good way. This is the same way that we ran everything on the production truck. We ran with 4 Metrons in there, 1 link to every Metron, and then we meshed the additional 4 to everything else. So we're able to sit there and come up with a 384 squared router with the Metrons in the middle. All right. This over here is a 1,152 squared HD router. So you can start seeing how big of a system that you can build. Somebody once tried to tell me, oh, you can't build that big of a system. Well, no, you really can. Just pure meshing, 48 by 48 squared HD router, non-blocking, 3G 48 squared router, again, 60 squared 3G, 72 squared HD, 72 squared 3G. You can just see that we're using more links there. At this point in time, a lot of people are always wanting 3G. So it'll never hurt you if you're building an HD. It's a little cheaper to run it non-blocking per se. to run less links, but it's not that much more expensive to just make it a full 3G router. And you can see it just keeps growing. Once you start adding Metrons here, it just grows and grows. 96 squared router, just 4 links to 1 Metron. So let's say you wanted to start topography like this. Everybody just outlying, nobody interconnected. You could do that with the central core Metron. And here's a 768 square 3G router, 8 Metrons sitting inside of that one. 1,000 plus squared router sitting here. So you can just start building these very large systems with MeteorNet. And it really, truly is up to your imagination on what you choose to build with this system. We're just giving you the building blocks. I really love the idea that MeteorNet, when they show it, or when we showed it as a router, they showed it with Legos, because these are the pieces. And you get to build what you want to build with them. The customers have come up with things that we didn't initially perceive what we were going to do, right? It's just the building blocks to build whatever you want to build. So hopefully you guys have enjoyed everything we went through today. That's pretty much it for what I've got going on. If there's any questions, I'd love to get into any more questions that we got going.
Sure. Integrating artist comms through MeteorNet. I know in the older packages, there was always a pair of ports on the unit. If you wanted to do more, like a coax and a Cat5, right?
You're talking about the compacts have AES3 built into them over here.
Right.
Specifically, and they're Cat5, just like our AES3 cards inside of the artist frame.
Right.
But
isn't there a coax there also?
There is no coax AES on here.
There used to be. Maybe it's in the modular.
Yeah, I think the modular had it.
So if I wanted to put more than
a
whole bunch of panels in one location,
well, it's easier to do that now. I would highly recommend running an AES67 card. Running an AES67 card to a network trunk port, passing that through to another network port, going to a switch and adding however many panels you want.
Right. Now, if you already own legacy artists, how would you distribute them? You wouldn't.
Well, there's no legacy artist.
Sure there is. Non-AES67 panels.
I consider legacy being things that we're not currently.
I know. I was on a show. I was on a show last year, and the audio guy turned to me and he looked at our 6 different artist frames and he said, "I'm sorry, we have to use this legacy intercom. I'm waiting for my artist 1024 to come." And I said, "I don't really think that's old, is it?"
No.
To some people, they're thinking it's old.
No, it's definitely alive and kicking in a huge part of the family.
Sure.
It's still, in my opinion, fairly advanced for the time, and so I kind of think when you say like artists, this frame right here was the first frame to have AES67 in it, and still has AES67 in it. But what we're really talking about is not legacy. We're talking about just a different format to get it to my panels, right?
Correct.
So, okay, let me give you a great example of an interesting way to do that. An interesting way to think about it is, yeah, we could come out AES3 on a compact. Okay, cool. There's 4 ports there to do that with, and you can hang 4 panels off of this one box. But if I wanted to do that with a Micron, what I would really think to do would be to use, I think Direct Outputs makes something that is a MADI to AES3. That is a bidirectional AES3. and then I would use a MADI card on my frame.
Right.
Because remember, in the frame, you can associate those ports even on a MADI card to panels.
Right.
So I'm not tied to just 3, right? I'm tied to
Right.
64 when I
Right.
use the MADI. Then you can say, well, I don't have the MADI. I'm gonna say, well, then let's look at getting an Andiamo on both ends, right?
Right.
There you go.
Okay. Is there a new version of hardware in the pipeline to use a 12G SDI single link to replace the quad 3G, as in 4K?
That's an interesting question.
We're waiting for an interesting answer.
I'm waiting for the NAB.
There we go.
Next question.
I thought this was NAB.
This is our virtual NAB the next 2 weeks.
Uh,
Them 4.
I know
this,
nothing.
your band, your entire presentation we just saw is part of the PDF you put in the handouts section. So somebody was saying they couldn't find the band wide calculations in there. It's in the end section of it, I believe.
And
Right.
we'll link on our website too.
Yeah.
Yeah, the bandwidth calculator is in the handout section.
Yeah.
So.
Oh, the
And,
calculator's in there, yes.
And the PDF should have included all of the slides, including everything for the build out.
Was that the
put the
MediorNet
presentation
PDF handouts?
Yep.
Yes.
Okay, they'll both be on a zip file along with the video on our website tomorrow.
All right.
So how do we do?
We're doing good. You have 30 more minutes to go. So you're 3 hours.
I sped through my last thing because I ate up an extra 30 minutes that you told me I didn't have, Pete. So
Exactly. No, it was great. It was great, and we pretty much got all of the information. One person said, "Great overview of this flexible fiber routing system." One way to put it, I guess.
I wonder if I know that person. I think my mom was viewing.
The flexible fiber routing system also does all of your video in-bed, debed, syncing, everything. It's all built into the little fiber ends of the fiber. Exactly.
God, hopefully that was my boss, or at least hopefully he's still watching.
Jeff Jones.
And you got you got a couple compliments on your presentation style overall too, man. I'll tell you what, you have been putting in the hours these weeks. I know everybody is just going 100 miles an hour, and I can hear it in your voice. And you really pulled together a lot of information really quickly. And I'll tell you what, I appreciate the job you did, Jeff, because this was really outside the norm of training, the outside the norm of sales, outside the norm of marketing. I mean, excellent job. I walked away with a really good understanding of this system that I didn't have when I started. And I am convinced more than ever that this is the type of hardware we're going to see implemented more and more, because it starts converging that the AES67. Your MADI example was really good. You know, we have so much more opportunity to interconnect, and it's gonna require thinking differently though. You know,
I love the example of
one level, right?
One giant rack of your full system router, and then you just split it apart and put it where all the inputs really were.
Mm-hmm.
And it was so obvious. Why not?
All with redundancy, all with the ability to have that, I should say, and that design. So thanks again, Jeff, for coming in and sharing this with us. And folks, reach out to Riedel when you're looking at designing these systems. This is obviously something where they're out there. They connect with the office out in Burbank. Get connected with whoever they'll put you in the right zone of coverage, if you will, with the people. And there's a lot to it, but I'm certainly much less intimidated now after walking through this with you, that it's got a place, and build it.
I'm glad to hear it. It's a system that can really do anything you want it to do. It's those Lego blocks that we talk about, and The sky's the limit. I can't put it out there enough though to everyone. Call us. We will definitely help walk you through any little idea you have. There is not a project out there that we're, you know, scared to tackle.
Well,
We're definitely looking.
I have Fios fiber in my apartment here. I want to put a Micron in the house here and connect it all to the world over my Fios fiber instead of the lousy one TV set they give me.
Oh, I love you. Oh,
we'll get
man.
it in there, Pete. Just call up Patty.
There we go. It'll come.
There you go. So, well, I think we'll call it an afternoon, an evening, wherever you're at. Thanks again, Jeff, and we'll look forward to connecting with everybody tomorrow on our next series of topics. QLab, I think, is one of them. Then we're doing our first town hall tomorrow night, where it's kind of an open mic night, if you will. People can call in on Zoom. We're going to talk about state of the industry, to hardware, to whatever really, people are passionate about and what they're thinking, huh, Pete?
Oh yeah, I'm ready.
There you go. You are ready. So that's it. Everybody have a great evening and thanks for joining us. So long.
See you all later.